Hello and welcome to Wednesday's edition of Cracking the Cryptic. Now the last 2 days have been basically warm-ups for this one. We've done between lines, we've done knight's moves. Now we get to do both with added arrows as well in the latest puzzle by Phistomefel. This puzzle of course is 5 out of 5 for difficulty. And one of the emails we've had recommending this one to the channel said that I might need to try not to cry when I solve this, I presume that was talking about the beauty of the puzzle, but it's just occurred to me it might mean that it's just so monstrously difficult it makes me cry. Well, I hope it's the former, not the latter. We shall see. Have I got anything to tell you about today? Not really, actually. Just have a look over on Patreon, especially try and become a patron before the end of the month, because on the 1st of March we are releasing a new Sudoku puzzle hunt for everybody. And the testing reports are very fine indeed, so I think you're in for a treat. Well, I know you're in for a treat, and I'm looking forward to the feedback. Now, the rules of this one, what are they? Normal Sudoku rules apply. Cells separated by a knight's move in chess cannot contain the same digit. So let's just run through what that means quickly. Let's imagine that square's an 8. If that square was a chess knight, it could jump to all of these yellow cells. And therefore none of these yellow cells can contain the digit 8, because if they do, well, not only is that going to break the arrow clearly, but these are a knight's move apart, and that's not allowed. Now, digits on a line between two circles must lie between the circled ends, i.e. greater than the lower of the two circled digits and lower than the greater of the two circled digits. So let's look at this one here. Look, let's imagine this was a 3 and this was a 6. Then these two squares on the line between the circled digits would have to lie between 3 and 6, not equal, so we couldn't have 3 up there. That would not be allowed. It would work according to Sudoku rules, but not according to the rules about the between line. So these two actually in this instance would have to be a 4-5 pair. And that's how that would have to work. Now we've got 2 more rules. We have got cells separated by a knight. Oh, I've done that one. No, we've only got 1 more rule. Sorry, I can't read. We've got the digits along an arrow add up to the digit in the associated circle cell. And digits can repeat on an arrow if allowed by the other rules. So let's look at this. No, let's look at this arrow. It's perhaps easier to see. We've got to add up those 3 squares, and whatever these 3 squares add up to, we put in that circled square. So if this was 1, 2, and 4, we would have to put 7 in there. And then this arrow here would also have to add up to 7. And that's how the rules work. So do have a go. Allow yourself some time for this one. I've done the same, starting this video slightly earlier than usual. Now, with that, let's get cracking. The way to play, of course, is to click the link under the video. If I didn't say that, I've no idea what I've said, what rules I've read out. This doesn't bode well for a Phistomefel. Now let's have a look. So, okay, now I accept this is probably not the place to start, but I am noticing that this circle here, if we look at this arrow, now you might think you could do something like that here and put a 4 in here, but you can't, because these 2 squares are a knight's move apart. So in fact, if we look at these 3 squares, because those 2 are a knight's move apart, this one obviously sees those 2. These must be 3 different digits. Now if they're 3 different digits, the minimum we could put into them would be 1, 2 and 3. Therefore this circle must always be at least 6. And this one we looked at in the introduction. Those 3 squares obviously have to be different because they're all in the same box of the Sudoku. So we've got the same thing there. These 2 are a knight's move apart, so they can't be the same digit. And that seems to be as far as the arrows take us. So we are going to have to look early at the between lines, which are slightly terrifying. Now, okay, let's try and do this in a structured way. What can we learn about the between lines? Can we learn anything, in fact? Ah, right, okay. Well, I can see something. I can certainly see something about this one. Same. Oh, right, okay. So there is something very clever indeed about these between lines. both of them. Let's look at the top one first. You can 1, 2, 3, 4, 5, 6 digits on it. Now the question that occurred to me is, can we repeat a digit on this between line? And the answer, believe it or not, I think is no. Because every single cell on this between line, due to the knight's move constraint, sees every single other cell. Now we're going to have to test this. I mean, it's fairly clear with this one. I mean, if that's a 1, where could we put a 1 in the rest of those cells? Well, we can't put it in the same box. Those are a knight's move apart. That's in the same column. So this one sits alone. This sees those two by knight's move, these two in its box, that one in its column. You can just see how this is working. It's just beautiful. That one sees those two, that one sees those two, that one sees those two, and Sudoku rules out the rest. So these digits are all distinct. So they are 6 different digits, which means the digits we put in the circles have to allow us to put 6 digits between them. So we could never put a 3 into one of these. Or a 7, I suppose. Because if we did 4, 5, 6, 7, 8, 9, this would need to be a 10. Similarly, if this was a 7, obviously, we could go 5. Oh, what am I doing? If that's a 7. We could go 6, 5, 4, 3, 2, 1. That would have to be a 0. We can't put 0 in this puzzle. So these two squares have got to be 1, 2, 8, or 9. Now, is the same thing true down here? I thought it was when I just had a quick look. Yeah, you can see it's this sort of... Yeah, it's the same shape. You know, if we rotate this shape, it maps straight down there. So the logic must be the same. So again, these have also therefore got to allow 6 digits between them, and they are 1, 2, 8, and 9. Whoops. Let's not introduce zeros into this just yet. Can we do something with... It would be very nice if these are all distinct. I think they are all distinct, aren't they? Certainly that one sees all 3 of the others. Yeah, they are, because although at first blush you might think this one could repeat here, it can't because these are on the same between line. So if we put 9 and 9 in there, it works according to Sudoku and knight's move, but it most certainly gives us a problem along this line where I'm not quite sure what we put on this line that would meet the rules, but it wouldn't be anything very sensible. So yeah, this is fascinating. Okay, so these digits are all different digits. And that's interesting for both between lines, because now, given these are all different, you can't put 1 and 9 on one of these. Because if you do, you're going to make 2 and 8 on the other one, and there aren't 6 distinct digits between 2 and 8. So the 1 is going to have to go with the 8, and then 2 is going to go with the 9. Now, I admit that doesn't actually tell us much, but it's something, isn't it? I'm quite tempted, actually. And it's not just because it's me, but I am quite tempted to try and colour this. Although, is that sensible? I think I'm going to have to do it, because if this is one of these is 1, 8, one of these is 2, 9. So between the 1 and the 8, 2, 3, 4, 5, 6 and 7, you have to put the digits 2, 3, 4, 5, 6 and 7. Between the 2 and the 9, you have to put 3, 4, 5, 6, 7 and 8. So you always have to put 3, 4, 5, 6 and 7 on both between lines. That's 5 of the 6 digits. And then the other digit is the 2 or the 8. But that means we do have to repeat 5 of the digits on this ring in this ring here. If these yellow ones here were just slightly shifted over, I think this might be easier to get traction on, but I'm definitely going to look at this. Yeah, we can do that one. Let's do that one. Let's do blue. Yeah, that's very pretty. Okay, good. So, yeah, this is what I was worried about would happen here. Although 5 of these colours have to repeat on this line, I don't see how to get a handle on that. You know, even looking at the orange and the blue here, the orange and the blue can't go in those 2 squares, but I think they can go in this one. I can't see immediately a reason why they can't. And they could be in any of those 3 as well. Maybe I just have to look at them, look at the colours individually. Maybe I need to get rid of grey as well. I'm not sure I like the grey. Okay, I'm going to keep the grey because I don't like yellow, because when I normally highlight cells that comes up yellow. Right, so this red, where can that go in this box? It can't go there, it can't go there. So red is in one of these positions. Yeah, that's really difficult. Red up here, maybe? Red. No, red has to be in one of those positions. This is... I don't think this is what we're meant to do. Now that could make me look very silly in about 5 minutes time, or in an hour's time. I don't understand how I'm meant to be able to map these digits down to these digits. Having said that, I may not understand it, but what else have I got to do here? This line just cannot be important. I mean, I only have to fit 2 digits between whatever I put in these. These could be as low as 1 and 4 and as high as 6 and 9. This arrow is just a disambiguating arrow. This arrow is just a disambiguating arrow. Now, hang on. Remember, we're looking at shapes like that. That's that shape. That's the same shape. This is the same. Right. Sorry. This is important. Because that means these weird O shapes in the grid are connected by the knight's move. And that must be important for the arrows. Because it's beautiful. That's so clever. I should have seen this a bit more quickly, I think. So we can pick any cell on the arrows here. And the point is that if you wanted to put 1 in here, it rules 1 out of the entirety of the rest of the arrow structure that it's part of. Similarly here, if we try and put 1 there, you can't put 1 in those 2, you can't put 1 in these 2. If you put 1 here, you can't put 1 obviously in the same box, you can't put 1 there. And that means that's going to put a serious restriction on these, because these digits now have to be 5 distinct digits. Which means even if we make them 1, 2, 3, 4 and 5, for example, that would add up to 15. So the minimum you can make these arrows add up to is 15. And if the minimum you can make the arrows add up to is 15, what does it tell us about these totals? They've got... Because, I mean, they have to sum... These cells here have to sum to an even number. Is that true, actually? Hang on. Yeah, it is true, because whatever's in here... Yeah, the arrows themselves must sum to an even number, because if this is an odd total, this will be an odd total. It will add up to an even number. So this can't add up to 15. So it has to add up to 16 or 18, which means this square has to be an 8 or a 9. This square also has to be an 8 or a 9. These see each other by knight's move. This is just lovely, isn't it? Now, that square can't be 8 or 9. Because it will see both of these squares. This one by knight's move, this one by Sudoku. There we go. There we go. This, which means it's on its between arrow now. This square must be the high one. So if this is the low one, this must be the high one. Now, can we get any further with that? Is there a way of telling which of these is high? If this one was high, well, I mean this one, it would see that. Maybe you'll have to colour these. More opportunities to colour. So if this was, hang on, sorry. Let's just do some colouring in. Let's make this one yellow. Maybe I remove the colouring from these ones. I'm loath to do that, but I don't see how to use this. I'm more interested in the 8s and the 9s. I'm going to look at the 8s and the 9s. So, make that one purple, make this one green. My stock colours. Now, if this is an 8 or a 9, it would therefore be purple because it couldn't be green. And that's impossible. That is unbelievable. Right, okay. You can't make this a high digit. Because if you do, where do you put it in box 5? You can't put it anywhere. This square can't be purple because it sees that one. This can't be purple because it sees that one by knight's move. So the only place you could put the purple digit would be here on an arrow. I can't put an 8 or a 9 there. The minimum I'll make those two squares is 3 if I put 1 and 2 in. 1 and 2 plus 8 or 9 is definitely higher than a one-digit number. So I think that's low. Therefore we can remove the colouring from it. And that, right, so now we know this must be high. And we've actually worked out the sort of parity of these between arrows now. And this one is now green. And that one must be purple. And therefore, green must be in one of these three, and it can't be there by knight's move, so green is up here. Now, what can we do next? Purple. Let's think about purple. So purple is in one of those three cells. And purple in this box. Oh, purple in this box is quite restricted, look, because of this purple and knight's moves. Hang on a minute. Purple is quite restricted, I think. Where does purple has to be in one of those two positions? That's on a between line. If that's on a between line, that can't be a 9. Or am I going crazy? I'm not going crazy, am I? If this and this are purple, and I think they are, then where does purple go in this box? It's got to go on the between line, so purple must be 8. Because if purple's 9, you'd need to put a 10 here in the circle. So that's actually extreme. That's our first digit. We've actually got digits now. Now 9 must be in one of those two. I will actually pencil mark that. Now let's work out where 8 goes then. So 8 is in one of those two cells. Therefore 8 is in one of these two cells. 8's down here. We know which digit 8 goes with. 8 went with the 1, 9 went with the 2. Now, okay. So what does this mean? That is the next question. We do anything with the arrows maybe. So this being a 9, these squares have to add up to 18. But the thing is, 18 in 5 cells you can do in 3 different ways. But right, this one. Sorry, this is where I should have looked. 8 on these arrows. 16 in 5 cells you can only do in one way. 1, 2, 3, 4, 6. And how do we combine those digits? 1, 2, 3, 4, and 6. I need to combine 2 of those digits to equal 8. Well, the only way of doing that is if this is a 2-6 pair. So this is a 2-6 pair. This must be 1, 3, and 4. Now, 2 here, C. 2 here, C is the 2-6 pair. So we get a 2 locked onto an arrow up here. And what else have we got then? It's still a remarkably empty grid, isn't it? There is still an awful lot of I mean, how on earth am I going to make any progress with this? Am I being daft here? Am I missing something obvious? Because there just doesn't... I don't see how... Maybe I've got to look. Where does 1 go down here? 1 is locked into one of 3 places. There just doesn't seem to be enough given information. There's nowhere near enough information. Phistomefel, what are you doing? How am I going to do this puzzle? There's got to be a 2 on this between line. That 2 there rules it out of those 3 positions. There's a 2 in one of those positions. There's got to be an... Oh, we know the 8 on this between line is in one of those 2 cells. Nine in this box. 9 can't go on the between arrow. It can't go in those squares. So 9 can't go on the arrow. 9 is locked into one of 3 positions. That is better than I was expecting. And I can see I've got to put a 9 in one of these cells. Look. How do I see that? Well, this 9 here is ruling a 9 out of all of those 3 because of the knight's move constraint. You can't put 9 on a between arrow. Right, okay, so we get 9s aligned. So we've not yet managed to put a 9 in row 3 of the grid. And it's going to, the 9 is going to have to go in one of those cells. Right. Okay. Would you be surprised if I wrote a 9 into the grid there? I'm quite surprised, but I think I can. Here's why. Is it possible to fill these 5 squares? We know there are 2 9s in these 5 squares. Is it possible that there's not a 9 in either of these 2? Let's look at that. The answer is no, because whichever one of these I put a 9 into will eliminate the ability to put a 9 in here. So there has to be a 9 in one of these 2 squares. Now look what that does to box 9. It does. I mean, it's not brilliant, but it moves the 9 out of row 7 of the grid into one of those positions. So there's definitely a 9 in one of these positions. Now this 9 is ruling a 9 out of those 3 cells, and those as well, I guess. So let's actually fill it all in. 9's got to be in one of those 3 squares. Again, I'm asking the question, where does the 9 now go? In row 7, it can't go there, it must go here. That rules it out of that cell. There's this little point here, actually, a small point. There must be a 9 now in one of those 2 cells, look. So one of the, I mean, it's the least useful digit, but one of these circles has got to have a 9 in it. Because if it doesn't, well, it's just because of the arrangement of the 9s in these 2 boxes. If you don't put a 9 here and put one here, you can see you have to put one there. The only other position is that there's a 9 there. So there's definitely a 9 in one of those. Okay, so what on earth do we do now? I've got this fabulous 9, and that's done almost nothing for me. Vienna. Can I do more with 8s? 8s. I don't think I can do more with 8s. 8s in this box. You can't put 8. Oh, maybe you can't put 8 in those 2 squares. Right, sorry, I can do more with 8s. Only a little bit more, but I can do more than I thought. Let's look at where 8 goes in this box. 8 can't go here. Now, can we put 8 in either of those 2 cells? No, because it will rule 8 out of both of those positions because of the knight's move constraint. So it looks like, at this stage, we can rule 8 out of this sort of T pentomino. But look, you can't put an 8 there, because then this arrow will have to add up to 9. And that's going to give us a problem in column 1. And you can't put an 8 here, because if you put an 8 here, what are we going to put on the other side of the between line? And how are we going to fill this? And this is one of the only combinations for this between line that won't work, because we can't put 8.5 on it twice, or even once. So 8 actually can't go in any of those cells, which means 8 is, I told you it was a minimal deduction, but 8 is definitely on the top of box 1. Now, what does that mean? It means that 8 can't go in there. 8 can go on the between line. 8 can't go on the arrow. 8 can't go on that, in that position. Because that will put 9 in the other place, and I'd have to do the 8.5 thing again. But 8 could go here, I think. If 8 went there, this would be a 1. This would be 2, 3, 4. 8 here, 1 here. Is there something wrong with that? 1 here. There's nothing easy wrong with that, is there? Bobbins. I thought I was on to something. I don't think I am. 8 down here. Can I do any better in this box? 8 in this box. This 8 reaches in, locks out a couple of squares. Oh, actually, this 8... no, good grief. Right, okay. I just don't think to look at this, but look where 8 goes in box 8 of the grid. It can't go there by Sudoku. And normally you'd look at these 8s and think, well, it might eliminate 1 or 2 squares by knight's move, but it isn't going to be enough. Well, it eliminates that one, and it eliminates that one. But these 2 cells on the blue line can't be 8s, because obviously 8 is in the circle. So 8 is in fact at the bottom. It's in one of those 2 cells. And that means it's not in these 2 cells, which means this square, yup, is an 8. That's ridiculous. So now, Now 8's in one of these 3 cells, is it? Okay. And that means what exactly? Does it mean anything? Does it mean anything useful? The answer is I don't know, but it's possible it does. I'm not prepared to give up on 8s now. That's, oh, sorry, I can do a little bit better. 8's not there by pencil marks. 8 can't be here in box 2 because of, you can't put an 8 in either of those 2 cells because it will eliminate an 8 from both of these positions if you do. So 8's actually now, good grief. 8 is completely placed in box 2 because it can't go here by Sudoku because there's an 8 in one of those 2. It can't go here by Sudoku because it would lock an 8 out of both of those 2. It cannot go on the long line because if it goes on the long line, the 3 length line, even if I accompany it with double 1, we'll get to 10. So it's not in those 2 cells. So it looks like at first blush it's in one of these 2 positions. If you put 8 there, it sees those 2 cells. And you can't put an 8 in box 5 anymore. So you can actually place an 8 there, which means you can place an 8 here. Now we know one of those 2 had to be a 9 from what we did before, so it's this one now. That's not 9 anymore. Okay. This 8, it sees that and gives you an 8 there. It also sees that, which gives you an 8 here. This 8 sees that one, yeah. That puts a 9 on the line. We knew there was one. It's there apparently. 9 is not here anymore. How many 8s have I got? The answer is a lot of them. I have only got, I can get that one. That's an 8. How many 9s have I got? Quite a lot of them. Okay. Wow. Right. Now I can get rid of the green highlighting there, and the purple there. 9. Okay, sorry, I don't even know what to do. But let that not stop us. We've got... I've got to put a lower digit in there. The thing is, that digit could be as high as 6, believe it or not. As so often with this guy, completely perplexed. What on earth? I'm not even sure where I'm meant to look. I don't even feel like I've done that badly to get to this point. 6 has got to be... 6 is in the same positions as 9's down here. But I really do know so little about 6's. I've done all the 8's. I feel like I must have to focus more on 9's. I don't know if that's a daft thought, but it's the digit I've got the most of by miles. So there could well be... could well be a way of... One in box 5, look. has to be in one of 3 positions. I'm very happy to notate that. One in box 8. I wouldn't normally look at this, but I can see it can't be on the between line. And this one actually does see those 2 positions by knight's move. I don't believe it. I don't believe it. 1 can only go in one place in box 8. You can't put 1 on the between line. You can't put it in those by knight's move. Now this little square can't be a 1 because it would eliminate a 1 from all 3 of those positions. And this square can't be a 1 because it gets mirrored into its circle. And there's already a 1 in box 9. I think that is a 1. That means this is a 1. Oh, come on, keep going. Yes, yes. Look, where does 1 go in box 9? It's ruled out of those squares, so it's got to go here. 1 is not there. One is not here, so 1 must be in one of those 2 squares, which means this cannot be a 1. It would rule 1 out of both of them because of the knight's move. So 1 is not here, 1 is there. Whoa, 1 needs to be in one of these 3, but I'm pretty certain 1 has to be somewhere on the line on this arrow, because otherwise the arrow would contain 2, 3, 4, 5, 6 as a minimum, and that adds up to 20, not 18. So I think, given you can't put 1 on those 2 squares, 1 has to go here. And all of a sudden, no, not quite. This one sees sees this square, so 1 is locked into this box. Now where do you put 1 in box 3? It's got to go at the top. Now where do you put 1? Yeah, this is by Sudoku. We're going to get all the 1s. I've got all of them apart from this digit in here, which is that one. Good lord, that is quite an incredible piece of sort of Sudoku gymnastics Phistomefel has performed with this one. Quite remarkable. Now, did I get anything from that? I locked a 9 out of this square, didn't I? So now 9 is not here. So 9s now. Let's focus on 9s. So these, I've got 5 9s, have I? 1, 2, 3, 4. Oh, maybe I haven't. No, I have. 1, 2, 3, 4, 5. So these are the positions of the last 9s. Is there something wrong with them? Ah, yeah, there is. There is. Can this square be a 9? Let's highlight these again, actually. This is beautiful. As usual with Phistomefel, these are the final positions of the 9s. Now, if you put a 9 here, what happens? And, well, there are 2 ways of thinking about it, really. You can see, because of the knight's move, that this will have to be a 9, and therefore this will have to be a 9, and this will have to be a 9, and you'll get a clash. But the other way of looking at it, I suppose, is, hang on, let me just get rid of that. Yeah, the other way of thinking about it is to say you can't actually, if you put a 9 here, you now can't put a 1 at all in column 7 of the grid. Because the moment you put a 9 here, the inability to put a 9 there removes it from this square. The 9 here removes it from this square, and there's nowhere in that column to put the 9. So however you do it, that is not 9. And if that's not 9, that's 9. That's 9. Oh, so there is... now hang on, let's do this slowly. If there's a 9 here, there must be a 9 on its circle. So the 6 is now down to 2 positions. This now can't be a 9, and that's a 9. All the 9s are done. All the 9s are done. All the 9s are done. I know I'm saying that over and over again, but I have not, even every time I get stuck on this puzzle, I'm completely nonplussed by it. I've got What, I mean, what digit am I meant to focus on now? 1s, 8s and 9s are done. I've got 1 6 in the grid and 2 2s in the grid. Don't tell me these 2s do something. 2s have got to be in one of those 3 positions. This is what I've been reduced to, is basically, you know, highlighting madness in the grid, hoping it leads to results. 2's in one of those 3 positions. I cannot see how that's helpful. I think this could be a very, very long video. Oh, no, hang on. 2 is on the between line. Sorry, I must keep remembering these between lines. So I can't put 2 in those 3 squares. You can't put 2 in the circle, or that would have to be a double 1, which it definitely can't be. So 2 is in one of 2 positions. Up here. We know we can't have a 2 in those 2 cells because that would repeat a 2 on these arrows. If I could lock 2 out of this square or something like that, that would be useful. Okay, golly, right. So, what do we do now? Are there cells in the grid that are weak? That would be a sensible thing to think about, wouldn't it? I suppose all of the between lines now. I haven't got the 2 on this between line. Ah, that was a sensible thought. There must be a 2 on this between line. Where does it go? It's not here or here. It could be here. If it's not here, it's got to be in one of those. No, I still don't know where it goes. This between line, you can see I've got the 8 on it. So those cells, the rest of the cells on it are 3, 4, 5, 6 and 7. So these squares down here are 3, 4, 5, 6 and 7. I'm not sure what that's meant to be telling me. This square does see the 3 and the 4 in this box. So this square has a little bit of a restriction on it. It can be 2, 5, 6 or 7. Yeah, I know, it's not brilliant. 6 can't go in that one. This square is interesting. Yeah, actually that square is a little bit interesting. Oh, actually it's more interesting than I just realised. I've just looked back this way and seen it can't be 3 and 4 this way. Right, hang on. This square I think has exactly the same restriction as this one, because it does see the 3 and the 4, which somehow I missed just now. But this can be 2, 5, 6 or 7 as well, I think. It can't be 1, it can't be 3, 4, it can't be 8, 9. Yeah. So this one's got the same problems as this one. But yeah, where does this digit go in box 7 of the grid? Whatever you put in there, by knight's move is removed from those two, and by Sudoku is removed from those two. So it has to have a friend here. These cells, let's highlight them. Whatever this is has to appear down here. And therefore, by Sudoku, it has to appear in these 3 squares. But it's a 2, 5, 6 or 7, so it's not in those 2 squares, so it's this square. So this square can't be a 6, so this square can't be a 6. Now I know that that's not amazing, but it tells us at least something. 2, 5 or 7 there. And so whatever this is, if it's not 2, that is unbelievable. Good grief. Right. It is 2. This digit is 2. Why is it 2? Well, let's try and make it 5 or 7. Let's just try that. If this is 5 or 7, it works the same way. Where do you put this in here? By knight's move and Sudoku, it's removed from these squares. So this square has to be red. It would have to be the 5 or the 7. And now look, you can't put that digit in box 5 at all. This sees those, this sees those, nowhere for it to be. If it's a 7, of course it works the same way. You can't put a 7 in there. This 7 sees those 2 by knight's move. Sudoku rules out the rest of it. So I think we can say this has to be 2, and that is very, very hard. And if I do cry as a result of that, it's going to be with relief. So 2. Now maybe that will help me to get further. Please, pretty please, let me get further now. It's not going to, is it? It's not going to. What? I feel like there should be something I'm seeing as a result of that, and I'm just not. Oh, is it up here? 2 can't go there. 2 can't go in here because a 2 in either of these squares removes the possibility to put 2 in those squares. So 2 is definitely 2 is definitely in one of these 2 positions. Yeah, good. Now look, 2, there's 2 things we get from that. Firstly, this is not 2, so the 2 goes there. Secondly, I've not yet managed to put the 2 in row 3 of the grid. It now can't go in these 3 positions because the 2's up there, so this must be a 2. That sees this by 2, so that gives us a 2. That gives us our cell on the between line. Look, this square's now a 2. This arrow, whoa! This arrow's now done. 1, 2. That's got to be a 6 to make 9. I think that means that's got to be 4, 5. But let's just deal with certain bookkeeping before we get to that. Oh, there's all sorts going on now because 6 is up here and you can't put 6 there because that will put 8 in the circle. So 6 goes here and this must be a 4, and finally I feel like I'm actually getting somewhere. Now let's come back over here. Let's look at this arrow, because we know that this arrow has to add to 9 and can't repeat 1, 2 or 6. So the only way that will work is with 4, 5. That rules 5 out from that one. Six is in. Oh, now maybe we can do better with regarding 6s. Look, 6 has got to be in one of these 3 squares, but there's a 6 here. So 6 is in one of 2 places. Okay. Don't know why I've removed 6. Oh, 6 is removed from there by this square. Look, so 6 in box 4 has to be in that domino. Ah, no, it doesn't. 6 here sees that one. So 6 is there. Remove 6 from all those cells. So now we place 6 in box 5 as a result of Sudoku and Knight's move. It's got to go here, which means that should be a 6 by Sudoku. Still got to put a 6 into the grid down there somewhere. It's got to be in one of those 2 positions. I'm slightly surprised that's not resolved, actually. It probably is. There's probably a 6 looking at these positions. So we've got 6s here and here, 6s here and here, 6s here and here to do. I tell you what I've got as well. I've got a 3, 5, 7 triple on this between line. So this must be 4. Because I know that all the digits are distinct, so if I just go back a bit, I can't repeat 3, 5 and 7 on the between line. So this is 4. I remember that logic from the prehistoric ages at the start of this video. This is not 4. So maybe this column, I've got 3, 4, 5 and 7 to place down there. 3, 4, 5 and 7. I mean, the thing I can see there is those 2 squares are the same, so I'm going to highlight those, because whatever goes in here obviously can't go in here, but needs to appear in the column. So blue must have a counterpart in one of these squares, but I don't think we know which one. There might be a way of telling, but I'm not immediately seeing what it is. Okay. So these squares are also 3, 5 and 7. Ah, so we can place the 2 down here. Sorry, that's been available for a while. I still haven't got a clue what to do. It's so strange to solve these puzzles and just have absolutely no real feel. I mean, this puzzle has hoodwinked me repeatedly. I've looked in the wrong places over and over again, and where I've found the right answers, it's been incredible to me. I mean, this 1 was restricted in this box, this 8 was restricted in this box. I mean, it just is so, it's baffling. Now, come on. I feel at least I'm in with a fighting chance now of solving this. Maybe that's wrong. Oh, come on, Simon. So what are we missing? sixes, it feels like, are the most restricted digit, but I can't see how to fix them. This has got to be 3, 4, 5 and 7. So these squares at the bottom of box 9 are 5, 6 and 7. That's not 6. What have I not used here? I've not used, I suppose I've not put this digit in, but this digit has to just lie between 2 and 9. It's going to be 3, 4, 5 and 7, isn't it? Yes, it is. Is it this 4, 5? Oh yeah, maybe this column actually. I should have looked at this a bit sooner. These two squares are a 3, 7 pair. I think if I could resolve this 3, 4, we might be in better shape. 5, 6, 7. Still have not got a clue how to solve this. 4 by Sudoku is in this pair down here. But that doesn't seem to rule it out of anything in this line. I know these squares, now I've got the 2 on this between line, these squares have to be 3, 4, 5 and 7 as a quadruple. Oh, does that mean that has to be a mirror of that? Is that right? These squares have to be 3, 4, 5 and 7. This one sees those 2 and that one. I think it does, so I think that is blue. Now that means that blue... Oh, good grief, this is actually nice. Now blue can't go here because of the knight's move. It's not 8, so blue must go here. And therefore this digit has come down to not being, it's got to be a 3 or a 4. It's not a 5 or a 7, I think. Is that going to help me? So close to helping in this column, isn't it? Unfortunately, it doesn't. 7. So whatever this is, four actually in this box is in one of 2 positions. I hadn't noticed that. But I don't think... I mean, I could colour the 4s. I have appreciated that, but I don't... Oh, look, 4 is up here. That might be helpful. Is it? That rules a 4 out of that cell at least. So 4 is definitely in this domino here. Is there a 4 somehow seeing this pair? I don't think so. Oh, there is a 4 though. Look at that, seeing that one. Oh, good grief. 3, 3, 3, 3, 4. Please don't stop. Keep going. Okay, well that was a little bit of a breakthrough. Now we know that these, well, not only do we know there's no 3s in those, we also know we can't repeat 3 again in these squares. So there's no 3s there. There's no 3 here. It's 4, 5 and 7. So this square must now be extremely restricted because it can't be 4, 5 or 7. It's on the between line. Oh, is that what I've been missing? Did I need to put a 6 on this between line, and has it been sitting here for ages? I bet that's what I should have done. Sorry if so. Yeah, I think it's been possible for me to place a 6 here for a while because there needed to be a 6 on this between line, and I just missed the fact it could only be here. And that does give me a 6 down there, which does give me a 6 up here, look. I may have done all the 6s now. I have. This square's now got to be 5 or 7, because it can't be 4. Now this is the only place 4 can go in the row. And 4 now must be incredibly difficult to place. Where, surely... Wow, 4 seems to be in this 2 by 2. We need to put 2 4s in here. But I don't think that there is a 4 poking in and disambiguating this. I could be wrong. 5, 7 here means this is a 4. 1, 2, 3, 4, 5, 6, 7. Yeah, just this domino left to do. This 3 gives us the 7 here though, and that might help us. So this square is a 5. And 7 must go. The 7 here gives us the 3 at the top. So this is a 5 or a 7. That means this is a 3 because we have a 5, 7 pair. That's a 5 or a 7. Now we should, I guess, have to get a 3 here. Gets rid of the 3 here. This is a 3. This is a 3. This is a 7. 7 and 5 go in. This is going to be interesting. Look, this 7 is seeing this domino, or not domino, but these 2 squares. So that's the 5. This is the 7. This is the 5. This is the 4. This is the 5. This is the 4. This is a 7. 7, 5. 5, 7. 7, 5. 5, 7. Please. Yes. Oh my goodness. That was absolutely brutal. That is as difficult a Phistomefel as I've seen in a while, actually. It's a brilliant, brilliant puzzle. The whole theme of it, which I think is these O shapes and how they affect the grid via the knight's move constraint, it's stunning. It's stunning, but it's so hard to solve, at least for me. I'm sure many of you will have got through that with more aplomb. Do let me know in the comments what I've missed. I think I definitely missed the opportunity to place this 6 earlier. But some of the logic with the 3s was really nice to find, and yeah, the whole thing, it's stunning. It's stunning. It just makes me feel stupid. And for that, I apologise. And thanks so much for watching. And we'll be back later, of course, with another edition of Cracking the Cryptic.